Welcome to week 3 of software engineering. Just going to review what we talked about last time. Okay, we've explored foundations of software engineering and gained insight into requirements engineering. Okay, now we're going to start looking at software design. It's that next step after software engineering. Okay, we're going to be looking at software design principles, architectural design approaches, unifying modeling language, design patterns, singleton observer factory. So these are just basically the components that we'll be using for the design part of the application. Okay, architecture layer design. What we're going to be doing is laying out a foundation for what the system is going to look like. So this is just an example. Okay, we have a job management system, and basically it has two functions. We're going to rate a print job, select a job management function, and then from there we're going to develop calls, build work order, send job description. Okay, not that important that, what are we doing, but the process that we're going through. This basically falls into the layered. Let's back up a little bit, get on the wrong screen, right? Yeah, architecture layered design. So we're layering down from the top the functions that we're going to need for based on requirements that we've basically developed so far. So this is a layer. The thing about this layer, okay, and looking at each one of those boxes, is we're looking for modularity, breaking the system up into smaller independent modules. We're looking for separation concern. Each module focuses on a single thing, that we don't have a module that says, I want to compute page costs and compute paper costs and compute product costs all in one function, okay, all in one to-do function. We want to break that out into individual so that what's represented in each box is a single function that needs to be programmed. Okay? So that's what we're looking for with the layered design. Okay, we're going to look at a architecture called MVC. And you've most likely, I'm almost positive, even though you may not have known it was MVC, has used this particular method to develop applications. Not necessarily, could be when you were using Python, when you were using Java, whatever programming language that you came up with, it is based on using MVC. And MVC stands for Model View Controller. The way it's set up, model handles the data and the business logic. View handles the user interface, and controller handles the user input and updates. So we're basically breaking the requirements for writing the code into 3 separate modules: model, view, and controller. Here here we have the user. The user is performing some function, entering a form, for example. The controller takes that form and based on the model, which is the rules, okay? And based on the rules for that particular one second, sorry. Yeah, so the controllers look at the model and the model is looking at the view. The model is basically, what do we need to do with the form once you've entered information into the form? What do we want to do with it? So the model processes, looks at that, pulls it, gives it to the controller. There's really a step here missing in that after we do the model, we actually do another controller function. And the controller may be reading the database, okay, to get information. That information is passed back in a view, and the view basically sees the view that came from the controller. Controller handles input, model handles data, and view displays results. So what's the benefit? Biggest benefit is organized code. You don't have all that code basically in one location where you're going in and trying to find things. You know that all your view items are together, all your model items together, and all your controller items together. So basically, it's a concise repository of where everything is that you're currently programming. Easier on testing, team collaboration, allows for reusability. Okay, here, this is, you probably don't know this, and maybe you do, but this is just an excerpt that I took out of my web design class. And basically, this is a controller function where we're we're going to soon talk about client server, but based on a request, we're going to be asking for a response that gives us a list of users. So this particular controller function, in having to go out and actually read the database to get the information that is needed, that is a controller function. That's what's happening here. Again, model, data logic, view presentation, controller requests. Together, they create an efficient structure. Okay, one of the other models that we're going to be heavily using both now and you'll be privy to in the future when you get out into my term, quote, real world, is client server. Client server is a model for dividing applications into clients, into a client and a server. The client makes requests. The server provides the answers to those requests. Client user interface, server handles logic. So if you look at the client server relationship, the client is on your laptop side, okay? And the server is on a box that handles all of the work. So you can look at the client as being the view, the user interface, and the server having all the logic and the database reads and parsing and all that sort of. All the work is done on the server side. The client is more of the user interface into that. The network, connects HTTP to TCP/IP. This is just another controller type function that is part of the client server model. So here's the basic flow. Okay, in another form, client sends a request, server processes it, server responds, client displays the result. Client server. Advantage, separate roles, scalability, easier to maintain. The key thing is separate roles. You're not doing all the work on the client side of the equation. Common design patterns. We have singleton, ensures that one instance of a class exists. Observer, okay, defines a dependency that when one object changes, it notifies other objects that the event has happened. Factory provides an interface for creating objects without specifying what the given class they're a part of. An example of this for factory, say I had a GUI toolkit. It has buttons, it has checkboxes, it has drop downs, okay, all this good stuff in it. But when I utilize that, that's a factory. It's not associated with any given class. It's basically for all classes, anybody to use, and really generic. The example of observer, social media, followers notify when somebody posts something, say on their website, or post something in Facebook, okay? Here's singleton, logger, where I have a logging function, okay? And that logging class is basically used by anyone and everyone who wants to log. System modeling. System modeling is the process of developing abstract models of a system. This is where we're drawing a picture. All the unified modeling language items are there so that you can present to the user, to the stakeholder, hey, this is what we're going to be doing in the system. Here is a picture form, in most cases, of how the system is going to look. That is the modeling part of it. And there's basically 5 types of models. There's context models, interaction models, structure models, behavior models, and 4 types. Model-driven engineering is a process rather than a model of how to do something. There's 4 that we're going to be concerned with right now. There's probably, just probably 15 different types of models. We're concerned with the activity model, the use case, the sequence diagram, and the class diagram. Excuse me, activity diagram, use case diagram, sequence diagram, and class diagram. Here, use case modeling, use case where we're developing originally to support requirements. Now it has moved from that to become part of a design. So it used to be for requirements. Now it's also for design. Each use case represents a discrete task that involves external interaction with the system. Usually it has the actor or a role. You see the term role. Actors in a use case may be people or a system, represented diagrammatically to provide overview of use case and in a more detailed textual form. Sequence diagrams are part of the unified modeling language and are used to model the interactions between the roles or users and the system. Sequence diagram shows the sequence of interactions that take place. Interactions between objects are indicated by annotated arrows. So here's an example for a sequence diagram. Okay, so you see here we have the role, okay, and we have that role interfacing with the system. So this particular case, the medical receptionist is viewing patient information. That patient information is coming from the database. It's defined here. In order to get to that database, you're going to have authorization. So we're going to ask for authorization and we're going to get it back. So this is the whole process just for this particular use case, okay, on how the data flows and how the interaction happens between the medical receptionist and the system, including authorization. Structural models. Structural models are class diagrams. Class diagrams, you should be familiar with that at this time, but if not, a class diagram is a file. A file has rows, rows, columns in it that defines fields. Okay, so a simplest form of a class is a file. So that's what's designated here. Here, there are the various classes that we're going to be using in the system. Okay, these designated numbers tells you a relationship. For example, a consultant can have many patients, but a patient only can have one consultant. You actually build in rules in the class that determines how the system should act. Okay, for here, a patient can have one general practitioner, but a general practitioner can have multiple patients. So you actually are defining a story of requirements with the classes on how they interact with each other. And based on that, you can get a review of the requirements of the system. Here is a consultation class, doctor, date, time. These are the columns that are going to be in the class, and these are the actions that can be prescribed, can be used using this information here as far as the fields. I can create new ones. I can have a consultant prescribe. I can record notes, and I can transcribe using the information that's in the class. Behavior models. Behavior models are models of dynamic behavior of a system as it's executing. You can think of the behavior models of having data. Some data arrives has to be processed by the system, and events. Some event happens that triggers the system processing. Data and events. I have some events. I need this data, or I'm going to be putting this data based on the event. So the event is basically driving the data that we need. That's a behavior model. Here's an example. Okay, activity model of insulin pump. This basically this is the flow. So this requirement that I have to have insulin pump processing. Here I have a blood sensor blood sugar sensor that monitors blood sugar. This is an action. I'm getting a sensor value. I'm storing it. Look at the boxes as being classes, and look at the circles as being actions. So I get the sensor, I save it, I compute the sugar level. I put that in a repository for blood sugar level. I calculate the insulin delivery. Okay, so these are basically the steps that we're going through, okay, that gives a description of what's happening with the requirement. This is associated with a requirement. Okay, this is highlighted. I mean, let me say, you have your homework assignment, which is going to deep dive into each one of these. This was just an introduction to the various pieces and components that we're going to be dealing with. There's really, it's one thing that you'll find out that I kind of not, now I say appreciate. Having to do a deep dive into some of these things, the only way you're going to get the best out of it is to do it. Okay? That's why we have a project. So we have our project. We're going to be applying these particular type model types and requirements, and we're going to be applying them to an application that we're building. That's where you can actually see, based on your particular project, how these things fit in. It may not make sense right now that, oh, yeah, I mean, what is an activity diagram? But when you have to build an activity diagram based on your requirements from your project, it all comes together. Okay, so look at this information, jot down in your notes any questions that you may have, and we'll jump into the, as I say, into the deep end of the pool, okay, during class, okay, or during our discussion forums for those who are going to be online. Okay, thank you, everyone. Have a great one. Bye.